Okay, for our last function, or for our last video, hopefully the last video, we're going to kind of walk through some of these things and figure out which equation does what. So it says match the correct equation and description of the function with a given graph. So notice here, these are squared functions. That tells me they are parabolas. And so when we start walking through these, we can see some other things, and I'll explain some more once we see these things kind of going down, but we're not going to worry about that yet. Let's take a look at g of x. So notice that the center point, which is this point right here, or the vertex, moved to the right 3, and that's all it did. So that means all the other points moved to the right 3. So if they move to the right 3, that means that it had to be a -3 inside. So E1 would be g of x. So this here is E1, or equation 1. And notice here the graph, and then we have to match the descriptions as well. So of course, this one here, what happened to the graph? It has only one x-intercept. That's what it's kind of looking like. It has an x-intercept for this one down here because it crosses the x-axis. So it has only one intercept. It looks like D4 is correct. And then is it translated down 3 and left 2? No. And then both intercepts x-intercepts are positive. So this says we have more than one x-intercept. So that's not true either. So that's this one. Okay, we're going to worry about this one at the top here in a minute. So over here, we can see the parabola moved to the right 2 and down 3, right 2 and down 3, up, down 3, and left 2. We did not go to the left 2, so that's not true. So we have the coordinate of the y-intercept is 0, 1. Let's take a look at that. Oh, there it is. Y-intercept is 0, 1 right there. So that is 0, 1. So it crosses the y-axis at that point. And both x-intercepts are positive. So notice it crosses right here and it crosses right here. So it looks like that's the one. So both of them, so that would be D3. So we figured that one out for D3. But we can also see what happened, as I already said, that it moved this way 2 and down 3. So that would be a -3 and a -2 on the inside. So -2 on the inside, -3 on the outside. So -2 on the inside, -3 on the outside. That looks like E4. So this would be equation 4. Okay. Now notice this one, what it does, it also crosses that axis, but notice that it's crossing the, it's over on the negative side of the x value. So the intercepts are going to be negative. But notice here, what does it do? It goes down 3 and back +2, really, because it's a +2. So it's a +2 -3. So I can go back up here, +2 -3. So it's got to be equation 2. So equation 2 is this one. And then let's see what the other descriptors are. So we've already used D3 and D4. So the graph has only one x-intercept. Well, that's not true. It crosses the x-axis twice. And then over on this one, oh, actually, we already used D4, sorry. So D4 and D3 have already been used. So D2, the graph of the function does not have an x-intercept. Well, it does cross the x-intercept, so that's not true. The graph of the parent function is translated down 3 and left 2. So down 3, left 2. So that would be that one. So I believe that is D1. Is that correct, or was that D2? Yeah, D1. And so that just leaves 1. So we haven't really talked about this too much. Notice in this particular case, this f of x is the only one that's left over, and we haven't used equation 3. So that's got to be equation 3, and does not have any x-intercepts. It never crosses the x-axis, so therefore it's got to be D2. And we're going to talk about this later on, but notice that this point right here, which is the vertex, did exactly this. It moved to the right 3 because of that minus. It moved down 2, right 3, down 2. And notice what the negative did is it caused it, instead of to go up, it inverted it, and it inverted over this horizontal line right there, because before it was actually going up there, but it actually inverted it to start going down. And we'll talk about that in the next part. And then finally, we have a couple more different types of functions. We have the square root of x, which we've already seen. We know that 10 plus the square root of x is going to cause it to go up 10. We know that x plus 8 is going to cause it to go to the left, right, in the negative direction, 8. Okay, so this would be my parent function. Okay, and that's what we would have there. Okay, write a function that translates the graph down 7.5 and right 2.5. Of course, if it goes to the right, we have to remember that, so we're going to use g of x. So if it goes to the right, it goes inside, and of course to the right is positive, so therefore it's negative. Remember that right and left are always the opposite. And then down 7.5, so it's going to look like that. What does this function do? It causes it to go up 10, and in the negative direction 6, to the left 6. Okay, notice here, again, we don't see all these things, but f of x minus 1 means that every single point goes down 1. X minus 2 means that every single point goes to the right 2. So every single point moves to the right. So be careful. This might be a challenge. What you always want to do when you're doing functions like this is notice that's an exact point that I can move 2 over or 1 down. I can move this one 2 over, 1 down, 2 over, or 1 down. Of course, it depends on which function I'm working with. This point, I can move 2 over, or I can move it 1 down. Pretty easy. This one's a little harder. I have a point here that I can see pretty easily that can move 2 over or 1 down. That's my only real point that I can move, and then I would just have to sketch that pretty carefully. Other than that, that's it. Takes care of everything. In this particular case, if we're writing the actual function, it's a parabola. So the parent function is f of x equals x squared. Notice it goes up 5 and to the right 3. So that would be to the right 3, which goes inside, and up 5. And there it is. That's all we have to do. And that's it for this section.